In this video, we'll discuss about the field effector transistor, JFET, junction field effector transistor. So, what is the difference between BJT and FET? BJT is a bipolar devices, FET is a unipolar devices. In BJT, the current conduction is due to the majority charge carriers, holes as well as the electrons. But in FET, either the electrons or holes are the responsible for the current conduction. And BJT is a current controlled devices, FET is the voltage controlled devices. So we'll see the classification of FET. FET is classified into JFET and MOSFET. JFET is a junction field transistor and MOSFET is a metal oxide semiconductor field effector transistor. And again it is classified into N channel and P channel, the JFET, and MOSFET is classified into depletion mode and enhancement mode. Depletion and enhancement mode further classified into two types based on N channel and P channel. We'll see what is a JFET in this video, means construction, working and characteristics of both N channel and P channel JFET. So what is the symbol of JFET? The symbol of JFET and in N channel and P channel is same like NPN and PNP devices. The identification is based on the arrow mark. This is N channel FET and the P channel FET, and this is the structure of N channel JFET and P channel JFET. So we'll discuss this about this structure in the next slide. N channel JFET. If you understand working of N channel, then P channel will be easy. Construction of N channel JFET. So here in this structure we can see a box. This is nothing but this is a silicon bar. This is a silicon bar made up of N-type semiconductor. So N-type semiconductor, which is having the majority as electrons. And electrons are negatively charged particle. So this silicon bar is called as a channel. This is called as a channel. The channel which is made up of N-type, and N-type is having majority as electrons, and so the channel is N, so the JFET is called as a N channel JFET. And there are two heavily doped region. These are the two heavily doped region which is made up of P-type. Since the channel is N-type, the heavily doped regions are made up of P-type semiconductor. And there are four terminals actually in the FET, which is two gate terminal and one drain and one source. And these two gate terminals are internally connected. So this dashed line represents the internal connections of the two gate terminal. So it is actually considered as a single gate terminal since it is internally connected. And source and drain, the other two terminal, what it is? The source terminal where the majority charge carriers enters the channel, and drain is the terminal where the majority charge carriers leaves the channel. So source where the majority charge carriers enters the channel, and drain where the majority charge carrier leaves the channel. So the direction of majority charge carriers is this way, means source towards a drain. So this is the direction of a movement of electrons or holes. Movement here it is electrons, and in P channel it is holes. So it should start from source and it should reach the drain. And there are ohmic contacts. Ohmic contact is nothing but the connection between the channel and the terminal. So there are totally 4 ohmic contacts which connects the terminal to the channel. And this is about the constructions. And one more is a depletion layer. By default there will be a depletion layer, and later it increases based on the amount of voltages which we apply across the terminal. And construction of P channel is same as the N channel. Here the silicon bar means the channel. This is made up of P-type semiconductor. In P-type semiconductor, the holes are the majority charged carriers and it is positively charged particle. And there are two gate terminals which are internally connected, and there is a source terminal and there is a drain terminal. And there are 4 ohmic contacts, and source is a terminal where the holes enter the channel, and drain is a terminal where the holes leaves the channel. And heavily doped regions are N-type. Since the channel is P-type, The heavily doped regions are made up of N-type and there will be a depletion layer. So we'll see first the working of N-channel with its characteristics. In the working of N-channel, actually there are three cases. It's based on the voltages which we apply across the terminal. So about the voltage, if we see this structure of N-channel, okay, there is a drain terminal here. So one voltage which we connect across a drain and a source. Anyhow, these two gate terminals are internally connected, and one more voltage we connect across a gate and a source terminal. So voltage which we connect across drain and source is considered as VDS, and one more battery is considered as a VGS. In some textbook it is VDD and VGG. Anything is fine. So drain and source voltage and gate and source voltage. So how to connect it means how to forward bias and reverse bias, that we'll discuss it. So we'll see the working of N channel. There are three cases. One is VGS, voltage across a gate and source, and voltage across a drain and source are zero. Means voltage is not at all applied. So what about the movement of majority charge carriers and its current flow? And second case is where VGS is still 0 and in changing the VDS value. And third case where we are changing the VGS as well as VDS. These are the three cases which we are going to discuss now. So now in an N-channel JFET, as I said, this is a field effect transistor. Either the electrons or holes are responsible for the current conduction. So here channel is N. So electrons, the movement of electrons decides the current conduction. Okay. So how to analyze this case? Case 1, when VD is equal to 0 and VG is equal to 0. Okay. So what happens when voltage is 0? There is no current at all if voltage is 0, because voltage is proportional to I. When voltage itself is 0, the current will also be 0, because when voltage is 0, there is no movement of electrons takes place from source towards a drain. So when VG is equal to 0, VD is equal to 0, the current will be 0. And this is a characteristics called drain characteristics, and that we plot for VDS versus ID. VDS is a voltage which we apply across the drain and source, and the current is ID, drain current. And when voltage is 0, the current will be 0. This is the first case. And second case where we apply VDS, and why it is positive, that we are going to discuss now. Means now we are going to connect a battery. So how to connect a battery, which polarity to be connected to drain and source. So I already said, the source is a terminal where the majority charge carriers enters the channel, and the drain is a terminal where the majority charge carrier leaves the terminal. So leaves the channel. So if you see, the direction is upwards, towards upward, means whatever the majority charge carriers, that should start from source and it should reach the drain. So the movement should happen in an upward direction. So there should be some repulsive force in this across the source, and there should be an attractive force across the drain. Then only the majority charge carriers can move upward direction. So based on this concept, we know equal poles repel each other, opposite poles attract each other. So this we know. So based on this, we are going to connect it. So here the majority charge carriers are electrons, and electrons are negative charged particle. So this to be repelled by the source terminal. So the negative of the electrons to be repelled, it can be repelled only by the negative of the battery. So this negative of the battery repels the electrons, and the electrons will be repelled and that to be attracted. So that can be happened by connecting the positive of the battery. So this plus polarity attracts the electrons towards the drain. So the movement of electrons takes place from source towards the drain. And now we are going to discuss about this case where VG is equal to 0 and VD is equal to positive. VG is equal to 0 in a sense there is no battery connected across a gate and a source. and we are connecting a battery across the drain and the source. We can write it as VDS or we can write it as VDD. Okay, so now we are going to discuss about this characteristics as well. So when the voltage increases, initially when the voltage is 0, current is 0 because there is no movement of electrons takes place from source towards the drain. When we increase the voltage, what happens? The electrons will little start moving towards, means it will start the movement when it gets some voltage. And when we increase it further, when the voltage increases further, then what happens? The movement of electrons takes place, so that will increase the current. So voltage increases, the current is also increases. And the depletion layer, by default there will be a depletion, and that will be increased due to this movement of electrons and also according to the direction. If we see this, the direction is towards the upward. So the depletion layer which is created, that will be created more across, means in the upper portion and less in the lower portion, because this electron movement is towards the drain in the upward direction, right? So the depletion layer will be more in the upper and less in the lower portion. Okay, and at one point what happens is both the depletion layer will meet. That is, when you keep on increasing the voltage, what happens? It happens like this. Means both the depletion layer will meet each other. It will meet each other like this. The depletion layer will touch, means we can say it is a pinch off. There will be a pinch off. Okay, so this is a voltage, so it's called as a pinch off voltage. Means when we increase the voltage, and at particular voltage, what happens is there will be a pinch off takes place. That voltage is called as a pinch off voltage. So after that, what happens is the electrons which started from the source, that doesn't reach the drain because there is a block here. The pinch off takes place, so the movement of electrons stopped here, means there will be a restriction. It doesn't reach the drain, so the current that remains constant in the remaining time. So when VG is equal to 0, there are three things. When VDS is 0, current is also 0. When you increase the voltage, current increases due to the movement of electrons towards the drain. And once the depletion layer increases and it attains the pinch off, then the current remains constant because the electrons which started from the source, it doesn't reach the drain. So this voltage where the pinch off occurs is called as a pinch off voltage. And the IDS is nothing but drain current, saturation state. IDS is the maximum current in the N channel JFET. VP is nothing but pinch off voltage. This is for the second case. And here we can see this region is called as a ohmic region. Ohmic region is nothing but, it's like a Ohm's law. Voltage is directly proportional to current I. When the voltage increases, the current also increases. And this is a saturation region, that means a maximum level. And this part will be the cutoff region. Okay, so third case where we are using the VGS as well VDS. So anyhow, we know the working of N channel JFET in the presence of VDS. What happens when we add VGS to? So VGS is negative because VDS is positive. So when we apply a VGS, means from 0 to negative maximum, what happens is whatever the process we discussed. See, in this characteristics, even this is a drain characteristics, but it is a family drain characteristics. Means there are more number of VGS value. So this is nothing but whatever we discussed till the last case 1 and case 2. This part where VGS is equal to 0. And now we are applying VGS, means VGS is increasing in the negative scale, -1, -2, -3, -4. So what happens is, whatever happened in the second case, the same thing happens in this, but everything happens early. So for example, see, this is a pinch off voltage for the first case. Second case, isn't it? This is a pinch off voltage. And if you see, when increasing VGS to -1 volt, anyhow VDS is there. In addition to VDS, we are applying VGS too. So what happens? There is a pinch off here. pinch off occurs early. And next, if you see this value, Vg is equal to -2, this is a pinch off voltage. And when Vg is equal to -3, this is a pinch off. So the entire process happens early. So it is called as these are all the pinch off value. So when you apply VGS in addition to VDS, the process whatever happened that will occur early. Pinch off, depletion, even the breakdown. Breakdown is nothing but the it's a condition that occurs when the maximum value of voltages are applied. So even breakdown occurs like this. So pinch off occurs early, and even the breakdown occurs early. So the ohmic region, as I explained, and this is a saturation region, and this comes as a cutoff region. So this is a working of N channel and N channel, construction and working and characteristics of N channel. And now we'll see about the P channel. The same thing, the channel is P, the heavily doped region is a N. So in P type, the holes are majority charge carriers that has to move from source towards the drain. So there should be a repulsion force here and attraction force here. So VDD, where the positive of the battery is connected to the source, because this plus polarity repels the holes towards the drain, and the negative polarity that attracts the holes towards the drain. So minus and plus, so we can say VDD or VDS equal to negative voltage. Since this is a negative, VGS will be positive. And the same three cases, VGS equal to 0, VDS equal to 0, VGS is 0, VDS is negative, and VGS is positive, and VDS is negative. And the same thing happens here, but the current conduction is due to the majority charge carrier holes. Okay, so when VGS and VDS both are 0, the current will be 0 because there is no movement of holes takes place from source towards the drain. And when we consider one of the battery, say VDS, in negative range, so what happens is the holes movements takes place and the current conduction takes place, depletion layer increases, the pinch off attains, and next when you apply VGS as well, then whatever the thing happened in the second case, it happens early in the third case, and there will be a breakdown too. So the characteristics comes like this, the down part. This is the characteristics for the P channel. And why it is in the second quadrant? Because our VDS value is negative. VDS value is negative and VGS is positive. Previously, VDS is positive. Okay, and this part, this is nothing but the transfer characteristics. This we plot with the help of the drain characteristics. So whatever the value we considered here, that same value to be considered in this x-axis. 0, -1, -2, -3. Same here. 0, 1, 2, 3. Even here it is 0, 1, 2, 3. So transfer characteristics or gain characteristics is nothing but it's input voltage versus output current. VGS versus ID. So in the drain characteristics as well as transfer characteristics, the y-axis is for ID. So this is a common scale, ID in milliamps, and VGS, we get the transfer characteristics in this way. IDSS is the saturation current. So same thing, but the majority charge carrier is different, and the values, negative and positive values, are different. So this is about the JFET N channel and the P channel. Thank you.